Welcome to Easy Higher Mathematics.
Modular lattice. Modular lattice is a lattice which satisfies this extra condition, that is A less than or equal to C, then A or B and C equal to A or B and C. We can interchange this bracket. LHS contains the bracket for second and third, and RHS the bracket for first and second. So same we can write in this form also, that is replace this OR by direct sum and this dot. So in this video we have three problems. One is N5 is not modular. Second thing is diamond lattice M5 is modular. And the third one is every distributive lattice is modular. So consider ABC from the figure. We take A less than or equal to C. This is a condition for modular. Now we take the relation A or B and C is equal to LHS value. Here first we calculate the bracket value B and C. So from the figure B and C is equal to and means least value, that is equal to 0. So A or 0, A or 0, A or 0. There is direct connection. R means the maximum value. R means the maximum value. This is the least value. This is the maximum value. So A or 0 is equal to A. Now RHS said A or B and C is equal to. What is A or B? From the figure A or B is equal to. A or B is equal to maximum value, that is equal to 1. A and B are connected with 1, that is maximum value 1. So A or B is equal to 1 and C. 1 and C. So 1 and C is this one, direct connection and means the least value. So 1 and C equal to C, which is not equal to A. Therefore N5 is not. The second one is M5 is modular. So this is the modular, this is the diamond lattice M5. So this is the condition A less than or equal to C. This we have to prove. The first case A equal to B, B equal to C, C equal to A. The result is trivially true. For this is the proof. Suppose you take A is equal to B. Our condition is A less than or equal to C. So A equal to B less than or equal to C. That means A less than or equal to C and B less than or equal to C. Substitute in this equation, that is B and C. So B and C is equal to what? B less than or equal to C means B is the least value. Therefore and means least value. Therefore B and C is equal to B. So A or B. But A equal to B. So by item patent law, A or A is equal to A only. Similarly, RHS said A or B and C. A or B is equal to what? A only. A and C. A and C is equal to A less than or equal to C implies A and C is equal to A. So LHS is equal to RHS. First case proved. So we can take B equal to C and C equal to. So other cases you can put similarly. Now you take the special cases, that is 0 less than or equal to A, 0 less than or equal to B, etc. Total 7 conditions. Total 7 conditions up to B, C less than or equal to 1. Okay, so first one A, B, C equal to 0, B, A. That means A equal to 0, B is equal to B, C is equal to A. Substitute in this equation, that is 0 or B and A. But B and A is equal to 0 because B and A, the figure is this one. B and A and means least value. So B and A is equal to 0. We can substitute here. So 0 or 0 is equal to 0. Similarly, A or B is equal to, here A is equal to 0 or B and C is equal to A. 0 or B is equal to, 0 or B is equal to, R means the maximum value. The 0 and B is the big one, so that is equal to B and A. But B and A is equal to same to B and A is equal to 0. So LHS equal to RHS. First we take what 0 BA only, 0 BA. So in the place of B and A, we can put this remaining cases A, B, C, B, A, C, B, C and C, A. What is case to A, B, C is equal to 0, A, 1. That is A is equal to 0, B is equal to A, C is equal to 1. The similar case, we can substitute this. So we can get LHS equal to RHS. So here 0, A, 1. So we can similarly put instead of A, we can put B, instead of A, you can put C. So these two cases, the result is true. Now case 3, ABC equal to 0, 1, A. We substitute the values. A is equal to 0, B is equal to 1 and C is equal to A. The similar way 1 and A, that is equal to A, because 1 is the supermost element and A is the least value and means the least value. 0 or A is equal to, R means maximum value, so this is equal to A. So substitute for RHS side, we can get the same value, that is LHS equal to RHS. So here 0, 1, A. 0, 1, A. So we can put instead of A, we can put B and C, because same value only we will get. And case 4, that is ABC is equal to A0, 1. That is A is equal to A, B is equal to 0, C is equal to 1. Substitute in this equation, we can get A or 0 and 1. 0 and 1, 0 is the least value, 1 is the supermost value, and means the least value, that is equal to 0. So A or A is equal to A. Similarly, A and 1 is equal to A. So LHS equal to RHS. In this case, we proved. Now, for here A01, so we can replace A by B and C. That is, the result is true for B01 and C01. The last case that is ABC is equal to AB1. So AB is equal to AB1. Here LHS equal to A is equal to A, B is equal to B and C is equal to 1. Substitute in this equation, we can get A or B and 1. So A or B, B and 1 is equal to B and means least value, and B is least value. Comparing to B and 1, B is the least value. So A or B, but A or B is equal to 1 from the figure. A or B is equal to 1. What is the figure? That is A or B is equal to A. By connecting A and B, 1 is the maximum value, that is A or B is equal to 1. So substitute here, value is equal to A or B is equal to 1. A or B is equal to 1 and RHS is equal to A or B and 1. That is A or B and 1 means this is consider this as a single element. So comparing to this element and this one, this is the least value. Therefore, therefore we can get the least value. If you take this is A, then A and 1 is equal to A only. Therefore, A or B and 1 is equal to A or B. But A or B is equal to 1 from this figure. So LHS equal to RHS. In this case, the result is true. Therefore, we can replace this ABC A combined. Therefore, the diamond lattice modular. The last one is every distributive lattice is modular. Every distributive lattice is modular. What is distributive lattice? A lattice which satisfies this condition A or B and C is equal to A or B and A or C. So here, if A less than or equal to C, this is the assumed condition for modular lattice. So A less than or equal to C. So we can take A less than or equal to C. A less than or equal to C means A or C is equal to C. Comparing A and C, C is the maximum value. So A or C is equal to C. Now substitute in this equation, that is A or B and C is equal to A or B and what is A or C? A or C is equal to C. So we interchange the bracket. So this is the necessary condition for modular lattice. So one thing, you must assume this condition By using this assumed condition, we have to prove this condition. Thank you.